Hey again, folks. Sorry about this. I knew I forgot to mention something in the last video, and I still have 5% left before my computer dies, so I'll try to make this go really quick. And I do have one other term I wanted to go ahead and get into, you guys. I think I said this backwards at the end of the last video. Teaches me for doing that on the fly. All right, we just talked about how temperature affects the speed of sound, but I just want to go through this again and have this on the note page for you. How temperature affects strings and tubes. Okay, so when the temperature increases, a string will lengthen. Okay, so when the string lengthens, if you think about that, the string velocity is dependent on the tension. So when the tension increases, the velocity will, when the tension decreases because the string lengthens, the velocity will go down. And if the velocity goes down, then you're going to end up with a lower frequency as a result in that. So hence what will happen is you will end up with it'll play flat because the pitch will decrease. When I say the term pitch is just frequency. Okay, this is the opposite for a wind instrument, because when you warm up your tube, then the speed of sound is going to be greater because the temperature increases. Okay, which, if the speed of sound is greater, that means there's going to be an increase in pitch, which is a higher frequency. Like I said, I think I said that, I might have said it the right way, but I don't want to go back and redo a 14-minute video that I already did just a little bit ago. All right, last term that we're going to deal with, Doppler effect. And Doppler effect has some cool effects on light too, but we're just dealing with mechanical waves here. When a Doppler effect happens, and there is a misconception on this, so make sure you don't say anything about the amplitude or the loudness of the sound wave or anything like that. Okay, this is strictly based on the frequency of the sound. The Doppler effect occurs when there's a change in frequency due to a movement of a wave source or the observer, one of the two. Okay, so basically what happens is this. If a wave source is moving towards you, so there's this nice little picture here of our police car, and his siren's going off. As the wave is moving towards, the police car is moving fast as well. So you end up with these bunched up waves in front, which the wavelength between them is going to decrease, so your frequency is going to get higher. So basically the observer here, would notice a higher frequency due to the police car moving wet towards them. Okay, this observer back here behind, notice the wavelength is going to spread out more, so it's going to get a little bit longer, and this person would notice a decrease in pitch or a decrease in frequency with the increased wavelength. Okay, so in order for the Doppler effect to happen, something has to be moving. Now, a police car could be stationary, and you could be running really fast towards the police car, and you would notice an increase in frequency too. I'm a little disappointed because I have the world's most annoying demonstration just to show this so that you guys can understand what Doppler effect is, but I don't have it here, so that's okay. Once again, Doppler effect is not due to intensity or amplitude changes. I mean, without a doubt, as the police car gets closer to you, it gets louder, okay? But the Doppler effect is just focused on the frequency, not on the loudness. Now, at some point, if this police car is moving fast enough, it is going to exceed this sound, and it's going to break through the sound barrier. So what happens is that produces what's called a sonic boom, okay? So when a sound-producing object is moving greater at the speed of sound, you end up breaking through the sound barrier, generating a loud crack, which that is what, if you were to snap a whip, that is what the sound is coming from, okay? So because the end of that whip starts to move so fast that it ends up breaking the sound barrier and you hear the crack. Other examples of that are firing a bullet. Yes, some of it is the actual combustion that occurs due to the bullet exploding to leave out of the gun, but most of the sound is due from the breaking the sound barrier, which is what a sound reducing or a silencer, even though they don't really silence it completely, is it funnels the sound waves out the end of the tube to reduce the sound. So one other cool thing, this is a picture of an airplane breaking through the sound barrier. Notice it looks like a cloud forms around it. Well, remember, sound waves are compressional waves. So what happens when we compress the air in the atmosphere, we compress it enough and get a high pressure regions, we can actually take the water molecules that are in the air in vapor form and condense them down into liquid form. So it forms a small cloud around the shuttle as it's going through. Okay, so that, like I said, there's a lot of other really cool things with this, but we're kind of running out of time, and I'm sure everyone's getting kind of tired of this online learning stuff. So I think I'll probably stop right there, and we will start getting ready for the quiz coming up here in a few days. Okay, that's it.